All right, so we are recording, and this lesson is the last of the factoring, which is probably going to be good news for a lot of you. I know factoring isn't a favorite thing, but it is going to keep coming up throughout the year. But this is the last of the new factoring material that we cover in Algebra 2. So what we're going to cover today are two topics. We're going to merge two different topics together. They're both fairly short, and they are sum and difference of cubes and factoring by grouping. Okay, so we're going to start off with what are the sum and difference of cubes. If you're going to recognize that this is another special case, we want to be able to recognize it. And we're going to build off of what we already know, which is a good policy. Anyway, by recalling what we know about the difference of squares. So we covered difference of squares in the last unit, and we know that difference means subtracting. Okay, so the word difference means subtracting, and squares was referring to something that we call perfect squares. Okay, and you would recognize the difference of squares, that it could be something like that. So x squared minus 4, and you would want to recognize it's the difference because it is subtracting, and that both x squared and 4 are perfect squares. And so you could write it like so, because 4 is 2 squared. Now, therefore, okay, so if we know what the difference of squares is, now we can go from that into the sum and difference of cubes. Well, now instead of just difference, now we have sum and difference. So we are going to be talking about both adding and subtracting. Before, when it's squares, we really only talk about subtracting. If you're adding squares, it's actually not factorable unless you invoke your imaginary numbers. But with cubes, you can factor them whether it's adding or subtracting. So this time the plus sign comes into play as well. And by perfect or cubes, what we mean are perfect cubes. Now, there's good news here, I guess. Maybe it could be good news or bad news. The bad news is that perfect cubes get really big, and they're also not really common ones. So when you think about your perfect squares, they're often in the times tables that you would have learned back in elementary school, middle school. Perfect cubes, people don't memorize those. So that's maybe the bad news. But the good news is that they get really big really fast. So there's really only about 5 of them that you need to know and recognize. So 5, that's not like a huge number. Here's what they are. 1 to the third power, that is 1 times 1 times 1, or 1. So 1 is a perfect cube. 2 to the third power is 2. 2 times 2 times 2, which is 8. 3 to the third power is 3 times 3 times 3, which is 27. 4 to the third power is 4 times 4 times 4, which is 64. And 5 to the third power is 5 times 5 times 5, which is 125. Beyond that, now there are obviously more perfect cubes than that, because you could have 6 to the third power, 7 to the third power, but they start to get big. If you think that something might be a perfect cube, you go grab your calculator and you just try it out on the calculator. Now notice a couple of these numbers are also perfect squares. So the number 1, so 1 squared is 1. So that is also a perfect square, and 64 is also a perfect square. That would be 8 squared, but it is 4 cubed. So 64 could be a perfect square. Well, it is a perfect square, and it is also a perfect cube. So we are looking at things that might look like this. I'm going to write in the middle of the page somewhere. So maybe x to the third plus 8. Okay, that would be the sum of 2 cubes, the sum of cubes, because x to the third power is a perfect cube and 8 is 2 to the third power, so that is also a perfect cube. And it works for both sum and difference, and you could see even the number out front, so you could see something like this. Okay, and that would be the difference of cubes, because 8 is a perfect cube and x cubed is a perfect cube and 27 is a perfect cube, so that would be the difference of cubes. Okay, so that defines the kind of problem that we're looking at. and that touchpad is not working. So how do we factor them? Okay, there are different ways to do this, and I've taught it different ways. So I've taught it with polynomial division. So I've done this after I've done polynomial division. Several years ago during COVID, some kids found something on the internet. It was some way of doing it. It was the most convoluted, difficult way. So I strongly discourage you from doing that. Here in my classroom, though, I've gone back to, after leaving it for a couple years, going back to something called the SOAP sandwich. And this is just an acronym, a way of memorizing how to get the factors. You can derive this. You can check out whether this works. There are formulas that you can memorize. I was never any good at memorizing the formulas. I think I learned them in Algebra 2 and then like immediately forgot them. But the SOAP sandwich does seem to stick. So what is that? What is this SOAP sandwich thing? Well, SOAP is an acronym, okay? And so it has like SOAP, okay? And that acronym stands for this. It stands for same, opposite, and then the A and the P go together, and that is always positive, okay? So SOAP is same, opposite, always positive. Okay, same, opposite, always positive. And then the sandwich is, I don't like, how do we go with the sandwich? So when you factor, you're going to have a little parenthesis, okay, and you're going to have a big parenthesis, and this one is going to be the sandwich. And you're going to have something squared and something squared. So those are like the slices of bread. So we're going to go square it, and then you're going to have your filling in the middle, like a PBJ. And I know one of the other math teachers at the school goes like square it, smush it together. And she'll clap her hands like that, kind of gets everyone's attention. Square it, smush it together. Square it, smush it together. My cat does not like that I am doing that. So that is like the sandwich part. So we're going to put this together. I'm going to show you some examples. You can pause the video and try to practice with some of them. But if you can remember that, square it, smush it together. And like, what are you squaring? Well, you're going to be squaring the stuff that's over here. Okay. So we'll go through some examples of what this looks like. Now, before we do that, though, a brief detour. Pause the video, and I want you to do a quick internet search on what does SOAP stand for. Just go into a browser and just do what does SOAP stand, but just not SOAP sandwich, just what does SOAP stand for. Okay, I'll pause for a moment. Okay, now I hope that you did that. And the reason we're taking this very brief detour is because for the last 2 years, I've done different things on formative. I used to have like an at-home version of the test, but AI has really gotten around pretty much anything like that. So I had a question on the at-home test that was, what does SOAP stand for? And the answer is same, opposite, always positive, but I had students just Google the answer, and I forget what the thing was that popped up. It was like subjective, objective, something like assessment protocol. It was something like that. And I had multiple students copy that down as the answer, which just tells me that they would rather look anywhere but in their notes for the answer to the question that I was asking them. And this detour was your caution. Should I put a question on your test that says, what does SOAP stand for? Do not give me some random answer. You're going to answer same, opposite, always positive. Okay. So minute and a half detour done. All right, so these are examples, and you are welcome to pause the video, especially after I do a couple of them. Okay, you might want to, like, I'll do the first 3, and then you might say, okay, I'm going to pause the video and try to do 4 and 5 on my own. I am going to do the work over in this space over here on the right, and then I'm going to erase the work for each problem as I go. Obviously, pause the video after the completion of each problem or rewind as necessary so that you can see what you need. So the first one is x to the third plus 8, and we of course want to recognize that as the sum of cubes. X cubed is obviously x cubed, and 8 is 2 cubed. So what we do is we start with the little parenthesis and the big parenthesis. These all are going to factor into a little parenthesis and a big parenthesis. And we'll do a check on one of these. I'll go through an area model and we'll do a quick check so you can see, like, yes, this actually does work. Now, for the first parenthesis, well, let's do the SOAP part. So SOAP stands for same, opposite, always positive. Now, what on earth is same, opposite, always positive? Well, what we're talking about are the operators, okay? And so you look at what the operator is. The operator here is a plus sign. So in this parenthesis, we need an operator, and it's going to be the same operator that we see right there. So that's the same. So if you have a plus sign, you're going to have a plus sign. If you have a minus sign, you have a minus sign. And of course, if you look at the examples on the left, I'm going to work you through a couple of those. Now, the next operators are going to go in this set of parentheses. Okay, and we're going to have an operator here and an operator here. And so we're going to have same, now opposite. Okay, so the opposite of a plus is a minus. And then the last two, the AP is always positive, which means this operator is always a plus sign. So what we're doing there is we're putting in the operators. This can become really helpful on a multiple choice test because you can eliminate answer choices just based on the SOAP part. If the answer has like minus, plus, plus, like, you know, that's not what this is. So same, opposite, always positive. Now, to get this parenthesis right here, we're just going to ask ourselves, what to the third power or what cubed gives me these expressions? So what to the third power gives me x cubed? That's just x, okay? And then what to the third power would give me 8? That would be 2. And remember, there's only about 5 of those numbers that you realistically need to know. So that gives me the first set of parentheses. Now, this is the sandwich over here. And over here, I keep doing that. And I make it worse. There we go. This is our sandwich. So we got a slice of bread and a slice of bread, and then we have the filling. So here's how we get the other parenthesis. This is one slice of bread. We're going to square it and put it right there. So square it. Now, this is my other slice of bread. We're going to square that, and it goes down at the other end because the bread makes the edges like the outside of the sandwich. So we're going to do 2 squared, and that's going to give us 4. And now think of it as a PBJ, okay? We're going to smush it together. And what are we going to smush together? The X and the 2. Okay, so slice of bread, and then smush them together by multiplying. So we're going to do x times 2, better known as 2x. And so square it, smush it together. Square it, smush it together. Okay, PBJ. Now, to show you that this actually is the correct factorization, what we're going to do is multiply the 2 of those together. Okay, and this is actually going to get into the next lesson. So I put the x plus 2, I put that down the side, and the x squared minus 2x plus 4, put that across the top. And we're going to multiply using the area model. So x squared times x is x to the third. X times negative 2x is negative 2x squared, and x times 4 is 4x. 2 times x squared is 2x squared. 2 times negative 2x is negative 4x, and 2 times 4 is 8. And what I want you to notice is right there, 2x squared minus 2x squared would be 0, and negative 4x plus 4x would also be 0, leaving us with x to the third and 8, and we'd add those up, and ta-da, x to the third plus 8. Now, we're not going to do that with all of them because we spent 5 minutes on this very first problem, which will be the slowest problem that we do. We're not going to check for all of them, but I did want you to at least see a check one time, and you are welcome to check as many of them as you want. So I'm going to go ahead and erase this, pause if you need to, and we'll just go erase all that and get into the second problem. They will go faster from here on out. So we have x to the third minus 64. We set up the little parenthesis and the big parenthesis. We do recognize that those are both perfect cubes. So we have x cubed and 4 cubed. And we're going to do same, opposite, always positive. So in this case, the same would be the minus sign. So same. And then opposite will be our next operator, and always positive. So same, opposite, always positive. And now for that first parenthesis, we ask ourselves, what to the third power gives me x cubed? Well, that would be x. And what to the third power gives me 64? That is 4. Again, only 5 numbers that you need to know there. And now for the other parenthesis, square it, smush it together. So we square the x to get x squared, and we square the 4 to get 16. And then we're going to get the filling for our sandwich by multiplying x times 4, which would give us 4x. And we are done. Ta-da! Soap sandwich. Okay, I can probably fit another one on here because there really is just one line. So let's do 27x to the third plus 125. And we have a small parenthesis and a big parenthesis. And we're going to do same, opposite, always positive. This time we have a plus sign. So plus, and then opposite, minus, and then always positive. Same, opposite, always positive. Now, this one's a little bit more complex because we do have more numbers in play, but nothing changes. We ask ourselves, what to the third power gives me 27? That would be a 3. And what to the third power gives me x cubed? That would be x. And keeping in mind that those are on the same side of the plus sign, so we're going to keep them on the same side of the plus sign. And then over here, what to the third power gives me 125? That is 5. And again, 5 numbers. I think I've used 4 of them so far. The only one we haven't used yet is the 1, and that's going to come up in the next problem. So I am trying to give you exposure to all 5 of those numbers. And now we got to get our sandwich. So square it, switch it together. When you do this, though, you want to be careful. Squaring 3x is 3x times 3x. So it'll be 3 times 3, which is 9. And then x times x, which is x squared. 5 squared is 25. And then we're going to smush it together. We're going to do 3x times 5, which is 15x. Ta-da! 15x. Okay, let's go. Now, what you might consider doing at this point, if you're doing this from home, is pausing the video and trying those last 2 on your own. Just give them a shot on your own and then unpause the video and just see how you did. All right, hopefully you did do that. Okay, so we have 64x to the third minus 1. We have a small parenthesis and a big parenthesis. Same, opposite, always positive. Notice that I am going through these faster each time. As you see them, as you handle them and practice them, your speed should improve. So now we ask ourselves, what to the third power gives me 64? Well, that would be 4. What to the third power gives me x cubed? That's x. And what to the third power gives me 1? That would be a 1. Square it, smush it together. 4x times 4x is 16x squared. And 1 times 1 is 1. That gives me my 2 slices of bread. And then we're going to smush it together by doing 4x times 1, which is 4x. Now, this last one, okay, we can do this last one a couple different ways. This one, we've got some common factors going on, okay? So let's start by looking for a GCF. I have 8 and I have 64. 8 is a common factor, so you could start by grabbing that 8, and that would leave you with x cubed minus 8y cubed. And then we would open up our small parenthesis and our big parenthesis. Same, minus sign, same, opposite, always positive. What to the third power gives me x to the third? Well, that would be x. What to the third power gives me 8? That's a 2. And what to the third power gives me y? That is y. And now we'll square it, smush it together. So x squared is just x squared. 2y squared, remember that's 2y times 2y, so that would be 4y squared. And then we're going to smush it together. X times 2y is 2xy. Okay, that one is also a little bit different because you've got the 2 is like on the back term, so we want to make sure like we keep all those terms together. One thing I've noticed a lot is that a lot of my students, a lot of you do stuff where you think about, well, it's on the left or it's on the right. And if you listen closely, I never say stuff like that. It's always about like what is attached to using mathematical operations like multiplication or adding, not, oh, this is always like a middle number. Now, let's say you missed the GCF. Okay, so you did not get that 8 out at the beginning. Then what would it look like? Okay. So in that case, you would have something like this. So you would have same, opposite, always positive. And you would say, okay, well, that'll be 2x because we didn't get the 8 out minus 4y. Okay. And then we'd have 2x squared. So that's 2x times 2x, which is 4x squared. And then 4y squared. So 4y times 4y, which is 16y squared. And then we would do 2x times 4y, which would give us 8xy. Now, notice here, right here, you have a GCF of 2 because 2 and 4 share a common factor. And over here, you actually have a GCF of 4. You have 4, 8, and 16, which would give you that GCF. If you take a 4 out of here and a 2 out of here and a 4 out of here, 2 times 4 is 8. So you can get that GCF at the end. Do not recommend it though. Okay, recommend getting that GCF at the beginning. Now, that brings us to the second skill, and that is factoring by grouping. This can be used to factor some cubic polynomials. It doesn't work all the time, but it is something that you would want to try. It is very easily done on the area model, and what I'm going to do on the next slide is show you the traditional layout as well as the area model, just side by side so you can see what they look like. A lot of you have said that you prefer factoring by grouping over the area model. Really, the area model is factoring by grouping. It's just laid out like as a square instead of as a line. So you might be able to see that now. So we're going to factor this x to the third plus 3x squared minus 5x minus 15. So what I'm going to do here is a little bit of a color trick. Okay, so I'm not doing any algebra here, and you would not need to do it. But factoring by grouping, what it means essentially is that you group like because this has 4 terms. So you group like the first 2 and make them their own group, and then you take the second 2 and they make a group, and then you look at each group and look for the GCF in each group. So in my red group here, I look at x to the third and 3x squared and ask myself, what is the GCF in that group? Well, this one has 3 x's, this one has 2 x's, so in common, they have 2 x's. So I would factor out the x squared, and if I have 3 x's and take 2 out, I'm left with 1. And then if you have like 3x squared and you take the x squared out, you're left with a 3. And so you'd have x squared times x plus 3. Then you would do the same thing over here. You would look at the negative 5x and the negative 15 and say, well, what do they have in common? Well, in this case, they have in common a negative 5. And then you would ask yourself this, negative 5 times what would give me negative 5x? That would be x. And then negative 5 times what would give me negative 15? Well, that would be a positive 3. Okay, now what you notice here is that we actually have an x plus 3 in common. And so that is technically a common factor. So I'm going to do another little like color change that is not mathematically related, like it's not a math thing. What color do I want to do it in? Let's do it in, no, that won't be distinct enough. We'll do this color, we'll do like an orange. All right, and minus 5. And then this is the x plus 3. And what I'm doing there is just like highlighting the x plus 3s so you can see better. Okay, those are now themselves a common factor. So I would factor out the x plus 3, and now I am left with x squared minus 5. And so that is like the traditional layout. I did not do any math in this step or this step, so it would really just be a 2-line problem as is. So it is a 2-line problem. It's not a lot of work, but my experience in teaching is that a lot of students do find it very visually daunting. Looking at a binomial common factor is something that a lot of students are not comfortable with. Now, just so you can see how that compares to the area model. So on the area model, all you do is put in the terms, and I just usually go like this. We do the x cubed, the x squared, the negative 5x, and the negative 15, okay? And then we factor the way we've been factoring all along. So you look right here and find your GCF. What is my greatest common factor? Well, that would be the x squared. And if you compare the two models, okay, what I just did right there where I had x to the third plus 3x squared and factored out the x squared is exactly what we did right there. We had the x to the third plus 3x squared and we factored out the x squared, okay? And then we see like, okay, well, what, like x times what gives me x to the third? That would be x, and x squared times what gives me x to the third, and x squared times what gives me 3x squared. Well, that would be 3. And then again, comparing the two models, we get the x plus 3. There's the x plus 3. So we took those same terms, got out the x squared, and we're left with the x plus 3. Now, where I think this is easier is because over here you have to deal with like the factoring out of a negative, and that can get weird if one of them is a minus and one's a plus. But with this model, like you can just do the multiplication. So x times what gives you x negative 5x? Well, that would be negative 5, and then just double check the negative 5 times 3 is negative 15, and there are your two factors. There's the x plus 3, and there's the x squared minus 5. And you can do that. And so you are free to pick whichever way you want. I think it's easier on the area model. I just do. I think it's visually easier for you to see it, as well as avoiding some of the dicey stuff that can come with the negatives. But I'm not going to make you do it a particular way on this skill. Now, one other thing to look out for is to make sure that you are factoring completely. So let's take a look at this one. If I have x to the third, we have 5x squared, 9x, and we have 45. So looking for that GCF between x to the third and 5x squared, they have an x squared in common. And now we can just multiply the whole rest of the way. X squared times x would give me x to the third. X squared times 5 would give me 5x squared. And then down here, x times, oh, crud, I made a mistake on this one. Whoops. Well, there you go. X times 9 gives me the 9x. And so this factors into x plus 5 and x squared plus 9. Now, what was the mistake that I did? Yeah. Okay, so let me see if I can fix it. I've got my scratch work off to the side here. So what I really wanted was this, and I'll try to edit the actual presentation. So I wanted those to be minuses, okay? Which means that we'd have a minus and a minus, which makes that a minus, okay? So because what I wanted you to notice was that this is factorable, like again, because right here we have the difference of squares, and that of course factors into conjugates. So we have x plus 5, and then this would be x plus 3, x minus 3. So I'll try to remember as soon as I'm done recording to go back into the PowerPoint and change that to minuses. If you need to kind of pause on this for a hot second. Yeah, just need to pause on that for a hot second because I did change it midway through. My apologies. In my defense, it's technically a day off and I've been working for almost 8 hours anyway. All right. So now that brings us to the assignment. Everybody's favorite part. So here's the assignment. For numbers 1 through 3, factor the sum or difference of cubes. So that is your soap sandwich. And as you're doing that, try to think about what those problems should look like. For numbers 4 through 6, factor using grouping. Be sure to factor completely. Hopefully I don't have typos in there. I'm sure somebody will let me know if I do. So there you go. Yeah, so factor by grouping. Now, for 7 through 9, factor the expression. This includes review of previous factoring skills as well as combining skills together. So you'll notice a couple of things about that. Notice that like you have two things that are just straight quadratics. This one is actually a quartic. It will work the same way. Just be aware of what you're looking at and ask yourself, can I factor it further? Now, 10. is choose the problem you are least confident in. Once you're done, look at all of those and just say, what do I really not think I got right? Okay, but you have to have an answer. Open Copilot and enter both the original problem with the directions and your answer. So you cannot put in for your answer IDK. You've got to arrive at an answer, okay? And you can use ChatGPT for this too. I just picked Copilot because that's what I know you have access to on your laptops, but you can use ChatGPT for this as well. Now, ask Copilot the following. I am an Algebra 2 student and need to check my answer to this problem. I think it says this problem. Tell me if I got it correct, and if not, give me feedback on what I got wrong. Then give me a similar problem to practice. So underneath my face there is the word practice. Now, so you're going to basically open Copilot and you are going to put in that prompt. And then you're going to put in the directions, both the original problem with the directions. So you're going to type in factor the expression. Okay. Or factor using grouping, be sure to factor completely, or factor the sum and difference of cubes depending on where you got your problem from. And you're going to put in the problem, and then you're going to put in your answer. And make sure you label them. Say problem, answer. Okay. If Copilot gives you bizarro things, it might not know like which part is the problem, which is your answer. Now, what are you going to write down on your paper to turn in? Excellent question. You're going to submit which problem you chose. Okay, which problem did you choose? So you just write like, I chose number 8 or number 9. Now, did you get it correct? That's a yes or no. Like, yes, I got it correct. Not. Did you understand the feedback Copilot gave you? Yes or no. Be honest. And for the year that I'm recording this, we're going to do a warm up about asking follow-up questions, but I might not do that every year. So just, did you understand it? And then copy down the new problem that you got and your new answer to it. So it should generate a similar problem to the one you were not confident in. You're going to write down what that problem is as well as the answer you got. And then hopefully the feedback, either you got it right the first time, so you just got a little bit extra practice, or you got it wrong, but you got some feedback on it. You're going to see if that feedback helped you get it right the second time. All right. as always, you guys know how to find me. I know this video was a little bit long, but we did cover a lot. And honestly, the last like 4 minutes of it was going over the homework. All right, let me know if you have questions, and I'll see you in class.